Okay, so page 156 has these rules. And these rules you will use to determine if something is going to be a solid or if something's going to be aqueous. Means, can you dissolve it? Yes or no? And so I'm going to go through these rules really quick. They'll all be there in front of you, and you just have to look at the combination of your cation, which is the element in front, potassium, calcium, iron, potassium. Those are all cations. They may not be listed on that table. They may not be listed, and that's okay, because one of the two we're going to be able to find. We might be able to find both of them on that table, or we'll be able to find just one of them on that table and how they relate to other elements. So, number one, the most important, not one of the most important, but a very important characteristic is that nitrates are very soluble. So, for the most part, if you put an NO3 ion with any metal, it's pretty much going to dissolve. It's pretty much going to be a solution. And when we write solutions out, we always write an AQ with it. So anything with a nitrate, when we go down through them, we're going to write an AQ because we're going to say, hey, that's soluble. That will dissolve. Okay? So using this chart, we can tell if it's soluble or not. So that first one up there, we could actually go and know right away. We don't have to look at K. We can look right away at it and recognize that it's an AQ that should go with it because it's soluble. All right. We could write a solid with it too, but this is when they're in water. So if I put KNO3 in water, then what it does is it breaks apart. And we've been working on that beginning of this week. We've been talking about solutions. And solutions are solids that break apart. And they break apart into one potassium and one nitrate ion when it breaks apart. And you guys have been working on molarity of the solutions. Okay? That would be how you do the first one. The second one says, if you have these ions involved, and if you look at them, they're basically group 1 elements with ammonium. Those are soluble. So if you got group 1 and they're in something, they're for the most part soluble. So if you look at the first one as well, and you didn't look at the NO3, but you looked at the K, you'd realize the K also enforces that it's soluble. It's soluble. Most of the time. There's always exceptions. We realize that. But we're going to say most of the time, this is what takes place. The third category says, they're all soluble, but there are 3 situations where they're not soluble. I said, hey, if you got a chloride, they're going to pretty much be all soluble. But if you put chlorine with silver, lead, or mercury, we find out that ion is not soluble. And if it's not soluble, we'll put a S with it, saying, hey, there's no way you're going to dissolve it in water because it is pretty much insoluble. Is there any up here that would be in that category? What's that?
You're talking ones that are
with the chlorine, with rule number 3. If there's any up here that we would say would be a solid because it's insoluble. Mike?
Gold chloride, or silver chloride.
Silver chloride, yep. So that one is insoluble. You can test water for chlorine, if it's got chlorine in it, by filling it up and putting a couple drops of silver nitrate in it, and it'll get cloudy. It'll get cloudy because the cloud would represent a precipitate. So.
Wait, don't we have another NO3 one?
Right. I'm not. You guys are going to practice on your own some of these. I'm just going to pick some of them out to describe what you're going to do. Okay. So you're going to finish the rest out. All right. Number 4. It says, like number 3, most sulfates, SO4s, are soluble, but there are 4 exceptions. If you got barium with it, if you got lead, mercury, or calcium. If those are the cases, then we say that they're exceptions to that rule, meaning they have to be a solid. They have to be insoluble. And then 5 and 6 are kind of the opposite thought process. 5 and 6 says if they're hydroxides, they're pretty much going to be insoluble. But here are cases where they can say they are soluble. So 5 and 6 are saying most of them are insoluble, where 3 and 4 are saying they're all soluble, and here are exceptions where they're insoluble. So they're kind of opposite thought process. And then number 6, it says if you got a sulfide, a carbonate, and a chromate, and phosphate involved, we're going to pretty much say that they're, when they say slightly soluble, we're going to say they're insoluble. They say, slightly soluble, we pretty much say they're insoluble, okay, at this point in time, when we write our letters A, Q, or S. So then, but we need to go back to Rule 2, and Rule 2 overrules Rule 6. You guys see what I mean? Rule 2 will always, if you've got a potassium, a sodium, ammonium, any of those ions with a sulfide, carbonate, chromate, phosphate, Rule 2 overrules 6. Yes, Allie?
On 5, where it says barium hydroxide, strontium hydroxide, and calcium hydroxide are marginally soluble.
We say they're insoluble.
Okay, just me.
Yep, marginally or slightly. When we write them out as formulas and that, when we do reactions, we're always going to write an S with them. If they're marginally or slightly, they have to be totally soluble to write an AQ with them.
So basically any hydroxide is insoluble except
Right.
for sodium.
Sodium and potassium, right?
Okay. Yeah.
Yep. So go ahead and fill in those points and we'll go through that. Go ahead and fill in all those, find them. Got a lot of examples to look at. You got 6 rules kind of to go along with and see what you come up with.
When do you put AQ and when do you put S?
If they're soluble, you write AQ. If they're insoluble, you write an S.
Oh, okay.
Yep. Cadmium sulfate, you guys have what? Solid or AQ?
AQ, no, solid.
Solid. Any questions on that?
No.
Iron hydroxide.
Solid.
K2S.
Aqueous.
AQ.
Why is that one aqueous?
As a potassium. Rule 2 overrules 6.
Was it overall? Was it because?
Because anything with potassium in it we'll say is soluble. The bottom one says these are pretty much insoluble most of the time, unless they're with elements in group 2. At the end it says if they're with elements listed in group 2, we're gonna, if they are listed with those elements, then we'll say they're soluble. Okay, group 2 overrules 6. Okay, Na2CO3, AQ, LiCl, AQ, aluminum sulfate.
Aqueous.
What? Why?
Because it says most sulfates are soluble. And then they give you 4 exceptions.
Phosphate is the one.
They're soluble since that.
Oh yeah, you're right.
Yeah,
Wait, no.
when you do 3 and 4, it says these are soluble, but here's exceptions where they're insoluble. And when you look at 5 and 6, 5 and 6 will say these are insoluble, kind of opposite, and this is where they're soluble.
Oh, I read that they weren't. And I was like,
Calcium carbonate, CaCO3.
Solid.
Solid. LaOH.
Oh, lithium.
solid.
There's lithium in it.
Solid.
Okay, I don't think that refers back to the hydroxide. Let me look at that.
It just,
It says most hydroxides are only slightly soluble. The important soluble hydroxides are NaOH and KOH. So I guess LiOH is not what they call an important soluble hydroxide.
So it is.
It's not in. So try to refer back to group 2 when you do the hydroxides as well.
So two.
It doesn't say to do that, but
Lithium is group 1 though.
I meant number 2 rule.
Number 2, yeah.
Number 2 rule.
So number 2 only overrides 6, right?
I would say
6
rule 2 overrules everything.
Everything? Okay,
So then why would it not overrule this one then?
No.
it does.
They just didn't have it written in there because they said it's not an important
So
hydroxide.
it's solid or aqueous?
It's not solid.
I'm confused.
So it's AQ,
Okay, awesome.
ammonium, AQ,
Oh.
Yep.
Solid.
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 Aqueous.
CaCl2, AQ,
Aqueous.
Solid.
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 Aqueous.
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 Solid. Okay.
Solid.
Solid.
Okay, you guys got it down, right?
Is the second from the bottom, that one's aqueous?
Because it's cesium.
When we take this test,
Yep.
everyone have to have these rules memorized?
No, you don't. Now, if you take the AP test, you'd want to know them. Yes, Al?
Are you, okay, going back to the lithium hydroxide?
Yeah,
Because the ones that it mentioned that are the important ones
Yeah.
are ions that are listed under number 2.
yeah.
So then lithium's not one of them, but like sodium and potassium are, but lithium's not. So wouldn't lithium still be considered, like that one would still be considered solid?
We could look it up, and we could see. I mean, we could get information,
Check it out.
Google it or something, and I'm almost positive, 97%, that it's going to say aqueous.
Okay.
So, if they included all the rules in that, you'd be like, but they didn't. So. I'll have to write the textbook writer.
I feel like those really
Why isn't lithium hydroxide important? I think it should be important. Okay, it should have its own. All right, I want to do this quick because I want to give you guys an opportunity to look at your solutions and start thinking about how to mix them up and that. We'll do that tomorrow. But I want to give you that. So what I want to do, why are we doing this? You have your list in front of you, and I took specifically elements off of that list of how many there were there. I don't know how many there is. There's a bunch. And then what I'm going to do is I'm going to give you 2 solutions that we would add together. Now, these are called double replacement reactions, or we got a precipitate that happens. Double replacement or double displacement. Okay? So what we'll do is we just write these on the other side, and we'll take this Li, put it with Cl, one of each to begin with, and then take the Ba and put it with the OH, one of each to begin with. So we go ahead and rewrite Ba and OH side by side, and then we put the Li with the Cl, and then we just go through and look at our charges. I'm not going to have you look them up, but I'm just going to go ahead and write them based upon their charges and balancing out, because you guys know how to do that. Alright, and then I'm not going to balance the equation, alright, for now. I'm just going to write out those 2 products. Okay, do you guys have BaOH above? What did we write with it?
Solid.
Do you have LiCl above? And that's what you do with those. You'd have, now if you didn't have them up above, you just look them up like you did before. That's called a precipitate reaction. If these are both found to be aqueous, then nothing happens. It's just a mixture of a bunch of ions floating around and nothing's taking place. Okay, easy enough?
Yeah.
Okay, we'll do one more, and I'll have you do it. Yes, John?
So like the formula for this, like for generally speaking, would be like AB plus CD equals CD.
Well, in the past I've kind of done it that way to look at it. But the metals replace the metals, and then if you know that, then it's pretty easy to do. Okay, the other one would be this one.
You do a lot of that. So yes. It's not complete.
And then I'll write them out just to save us time. And we're not balancing. Probably should balance, but I don't want to.
Why do you have
Do
still 3? Did you have to balance? Is that one? No, we're not balancing the whole equation.
Yeah, I'm not. We won't balance. You guys know how to balance, and so there's multiple things you have to do to get to this point. Make sure the charges balance out. Make sure the equation balances out, and that type of thing. So AlCl3 is aqueous and CaSO4.
Solid.
So that's what's forming the solid in the solution. That's called a reaction when you get a solid form in a reaction. Okay, and then we'll revisit that on Monday and start writing these in a little different way than you see it here. It's not really complicated to rewrite them out into a different form. So that is what we'll do.